Welcome back, guys. And in this lecture, I'm going to talk about image manipulation. So there are a lot of things that can be done with respect to an images and CV2 library, OpenCV library that we have been using. It's one of the lethal library you all will be able to find out, a lethal Pythonic library when it comes to images, dealing with the images. And that's the reason. So this library is like very much popular across our community. So whoever is trying to build anything with respect to the images. Now here, so in short, I'll be showing you a different kind of a manipulation that you can try to bring with respect to the images while like processing the images and converting the images from one format to the other format. So let me share my screen and let's get started. Now here, so we have to import first of all something from my previous lecture. So I'm going to import basically this libraries. All of this library is required, and apart from that, so I would like to import this show image function as well, because again and again, so I'll be using this show image function that I have already created, so which is going to showcase our images inside my Jupyter notebook. Otherwise, I can try to use a CV2 function directly for doing the exact same thing. Okay. Okay. Now, so let's try to read images first, and then let's try to showcase those images. So here, just for the testing purpose, right? So just for the testing purpose of this piece of the code. So here I can try to call CV2 and IMRead, and I believe we are pretty much aware about this IMRead function. And here, so I can try to pass one.jpg, the images that I have, and then I can try to store it inside a image over here and execute. Now I can try to call my show image function, and with the help of this function, my image, and then this image that I am trying to read, so I can try to showcase this particular image. Now I will be doing each and everything with respect to this particular image. Yeah, all of these operations I will be doing with respect to this images, and I'm going to show you a different kind of operations over here. So first of all, let me show you a different kind of a blurring operation. Blurring means, so it is going to take pixels or combination of pixels for a particular grid, or we say that as a kernel, right? So for x cross x or x cross y pixels, and it is going to normalize it by using the technique that I'm going to give as an input. So maybe by using a mean, maybe by using a median, maybe by using like a something different, maybe a Gaussian, right? So here, let's start doing it. Let's start like blurring this images with the help of different kind of a technique. So here, the very first technique that I can try to import is called as Gaussian blur. So Gaussian blur, and here, so I can try to pass my image. Yeah, I can try to pass my image, the image which I was able to read over here. So this is the image variable, and I was trying to read my own image. So I can try to call my images, and then in terms of performing a Gaussian blur, so I can try to give my kernel over here. So 9 cross 9, it must be odd all the time. And then here, so I can try to give my standard deviations, and it is going to GAUSSIAN Gaussian, and it is going to blur my images. So if I'm going to use a show image and then Gaussian blur, and here Gaussian, so it is going to create a little bit of blur effect, which is not very much visible. Now what I can do is I can try to increase a kernel size. So maybe a 21 cross a 21 I can try to give. And now if I'll try to show you, so now blur is visible little bit. I can try to even keep on changing this. So maybe I can give 41 cross 41 and then see the impact. So now my image become more and more blur. So here I can try to use a Gaussian blur technique, and with the help of that, so I will be able to blur my images. Now other technique that you will be able to find out called as a median blur. So CV2 dot median, so it is going to take a median of the data. So whatever kernel that you are going to give, so it is going to take the median of the kernel, and then it is going to do the blur. So image, and then I can try to give a kernel size over here. So maybe kernel size is equal to 9, let's suppose. Yeah. So median underscore blur blur, and execute, and here, so show image I can try to call, and then median median, and median blur is a name blur, and then I can try to call median blur, this particular one, so which is technically implementing a median blur operation on top of my images. So yeah, it looks good. A little bit of blur it is able to create. Now maybe I can try to change this one, so as a 81, and you will be able to see a drastic blur over here, right? A drastic blur over here. So here you can keep on changing a kernel size nothing but a matrices grid, right? So this cross this 81 cross 81, so this is the kernel size which I am trying to give. And instead of taking all the pixels, what it will do is for that kernel, so it will try to take the median value. And I believe we all understand that what is the meaning of the median. Okay, now apart from that, so there is something called as a bilateral blur. So CV2 dot bilateral filter over here, and then we can try to call images. So whatever images that we have, and then I can try to give a number of pixels in a neighborhood, and I can try to give a sigma value. So there is something called a sigma value for basically color and space. So 75 and 75. Now here I can try to save it as a by, let's suppose, and then show image, and here so by, and I'm going to call this variable. It is able to do a blurring, but it is able to do some sort of filtering operation, but I'm not able to observe that, by the way. So maybe I can try to increase this to a 90, and then let's see so what happens. So here you must be able to see that it has smoothened my images, or it has merged a lot of pixels, right? It has merged a lot of pixels. So you must be able to see that there is an impact that we are able to get. And again, so same kind of impact I will be able to see even with respect to a mobile devices. Okay, so